Good morning. Today we are going to cover section 10.5, solving trigonometric equations. So take the time to copy your title and your essential question. How do you solve trigonometric equations written in quadratic form? Copy example number 1 and we'll start once you are ready. Go and pause it if you need more time. So I need to find all of the solutions for this equation and all the solutions over the interval between 0 and 4 pi, including 0 but not 4 pi. So now write down the equation. We have the sine of x minus 1 equals negative sine of x. I notice I have sines on both sides, so I'm going to combine both sides on the left. So I'm going to add sine of x on both sides. So that cancels. And we have sine of x and sine of x will be 2 sine of x minus 1 equal to 0. And we're going to solve it the same way that we solve any equation. Move the 1 to the right, becomes a positive. So 2 sine of x equals positive 1. Divide by 2. Sine of x equals 1/2. And now we are going to evaluate. I'm going to place my x and y axis on the left. Just a quick 2 by 2. And I'm looking for the angles whose sine of the angle is equal to 1/2. Remember, sine, is that x or y? That is y. It has to be positive. So y, positive up, negative down. So therefore it has to be on quadrant number 1 or quadrant number 2. 1/2, is that your shorter side or your longer side? That is your shorter side. So therefore it has to be either pi over 6. And remember that we are working with radians. So 30 degrees, which is pi over 6. And 5 pi over 6, which is 150 degrees. So therefore my solution is x equals pi over 6 and x equals 5 pi over 6. Now we need to find all of the solutions. We need to be able to find the period for sine of x. What is the period? The period is 2 pi over b, which is 2 pi over 1, or just 2 pi, since the b is 1. So therefore we're going to place plus 2 pi plus 2 pi n, where n is any integer. So this solution is going to repeat every 2 pi. So where n is in, so if we want to be able to find the solutions, I can plug in a 0, a 1, a 2, a -1, -2. So let's go through and use the graphing calculator. We are going to use decimals. So if I go into decimals, graphing calculator, and I can take the time to type in the solutions or find the solutions by using the intersection method. Negative sine of x. And notice that my solutions are pi over 6 and 5 pi over 6. The same thing that we have here. So my solutions that I see here are pi over 6 and 5 pi over 6. I'm actually going to use this to find the solution instead. So now that we solve for sine of x, I'm just going to leave sine of x, and g of x will be 1 over 2. So my solutions are pi over 6, 5 pi over 6, but this pi over 6 repeats again over here. And then this 5 pi over 6 will repeat on the next period, and so on, correct? So this solution repeats over here, and then on the next period it repeats once again, and then on the next period it will repeat once again. This solution, 5 pi over 6, will repeat every 2 pi. It will repeat every 2 pi, and then every 2 pi. And therefore, this will give you all of the solutions for this equation, where n is any integer. Now, if we want to be able to find all the solutions over the interval from 0 to 4 pi, we are just going to substitute values for n. So we have x equals pi over 6 plus 2 pi. Now plug in a 0. That will give me my first solution. That cancels. So therefore we have x equals pi over 6. Now I'm going to use the second one, and I'll plug in a 0 as well. X equals 5 pi over 6 plus 2 pi, and I'm going to plug in a 0. That gives me 0. So it gives me x equals 5 pi over 6. Now they both are smaller than 4 pi, so I'm going to continue, and I'm going to plug in a 1. I'm going to place this over 1. That's 2. I need to have the same denominator, so therefore this will be x equals pi over 6 plus multiplied by 2 by 6 gives me 12 pi over 6. So therefore this will be 13 pi over 6. That's 2 and 1/6, so it's still smaller than 4 pi, so we can continue. X equals 5 pi over 6 plus 2 pi. Now I'll plug in a 1. Place it over 1. Have the same denominator, multiply by 6. So therefore x equals 5 pi over 6 plus 12 pi over 6, which will give me 17 pi over 6. That is still smaller than 4 pi, correct? That is 2 and 5/6. So therefore, I'm going to continue and plug in a 2 now. So therefore, x equals, and then we can continue until we get to 4 pi. If we get to 4 pi, 4 pi is not included. If it's smaller, we can include, but if it's bigger than 4 pi, we don't. 5 pi over 6, or pi over 6 times 2 pi, and now we're going to plug in a 2. That's 4 pi. We'll place over 1. And notice that this is already 4 pi, so we know that's going to be too big. But let's just continue on, just in case you don't recognize it. That gives me pi over 6. Multiplied by 6 gives me 24 pi over 6, which is 25 pi over 6. And that is greater than 4 pi. And therefore we can stop, because even if we add this one here, x equal to 5 pi over 6 plus 2 pi times 2. Well, this is already 4 pi, so this is going to be greater than 4 pi. We don't need it. We only needed the solution between 0 and 4 pi. So therefore, solutions where it's between 0 and 4 pi are x equals, I'm going to place that in the same notation. I'm going to place the smallest one to the largest one. Smallest one is pi over 6, then 5 pi over 6, 13 pi over 6, and the last one is 17 pi over 6. And if we go into decimals, and if we restrict our solutions, or your f of x, which is sine of x, I'm going to place a brace. 0 is less than or equal to x, which is less than 4 pi. That is the graph that we have. So all the solutions, which y value is 1/2, is pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6. The next one is no longer there. Now, notice that my x values are in ones. I need them in, they're in radians. And notice I'm going to the toolbar, and I want step, I'm going to type in pi. And as soon as I type in pi, it changes to the symbol pi, and we are in radians. So it's from 0 to 4 pi, and we only have those 4 solutions. The next one was already greater than 4 pi, 25 pi over 6, which is no longer valid. And that matches our solutions that we have here. Example number 2. So take the time to copy it down, and we'll start once you are ready. So I need to find all the solutions, and then I need to find all the solutions over the interval between 0 and 4 pi. So I'm going to copy the equation down. Tangent of x minus the square root of 3 equals 0. I want to leave the tangent by itself, so therefore the tangent of x equals, move this to the right, we can say positive square root of 3. And now I can build my x and y axis and find let's see, tangent. Tangent is y over x, and it's positive, so therefore it has to be in which quadrants? Correct, it has to be in quadrant number 1 or quadrant number 3. Now, have you memorized your tangents? We know that the tangent of 30 degrees versus your tangent of 60 degrees. I know that both of them are square root of 3. Which one gets the division by 3? The smaller one. So therefore, this is tangent of 60, so it will be my 60-degree reference angle. So therefore, it will be here and over here. So 60 degrees, but we're working with radians. So therefore, x equals pi over 3. So this is pi over 3. And this one is 4 pi over 3. Remember, this is pi, which is 3/3, and 1 more third gives me 4/3. Now, what is the period for tangent of x? The period is 2 pi over b, or pi over b. It's pi over b. In this case, your b is 1, so therefore it's only pi. So it's going to be plus pi, n, where n is any integer. So those will give you all the solutions. And we'll come back to this in a few minutes. Now, if we go into decimals and graph it, now I want to leave this because we need it from 0 to 4 pi. I'm just going to change the sign to tangent. And I want to leave this and go with square root of 3. So notice that we have 1. Those are the 2 solutions that we have. So therefore, we need to be able to find all the solutions between 0 and 4 pi. So far, we are in good shape. And you want to make sure that you are seeing the connection between the unit circle, and the graph. That's right there. Now let's find out the solution between 0 and 4 pi. So now that we have our equation, I'm going to get this equation and plug in a 0. So x equals pi over 3 plus pi. Now plug in a 0. Well, that cancels, so I end up with x equals pi over 3, which is our first solution. X equals 4 pi over 3 plus pi times 0. This cancels, so therefore I end up with x equal to 4 pi over 3. Now I'm going to plug in a 1. X equals pi over 3 plus pi. Now I plug in a 1. Well, this is going to be pi. I'm going to place over 1 and I'm going to multiply by 3. So therefore I end up with pi over 3 plus 3 pi over 3, which I end up with 4 pi over 3. And now I'm plugging a 1. 4 pi over 3 plus pi times 1. So therefore I end up with 4 pi over 3. I'm going to multiply by 3, numerator denominator, so I end up with 3 pi over 3, which is 1 pi. So therefore x equal to 7 pi over 3. They're still both less than 4 pi because this is 2 1/3. Now I'm going to plug in a 2. Well, this is already 2 pi, still fine, right? So I'm going to multiply by 3, so I end up with pi over 3 plus 6 pi over 3, which is 2 pi. So therefore x equal to 7 pi over 3. That's still 2 1/3, still smaller than 4 pi. Now I'll plug in a 2 over here. You probably already noticed something, right? And we'll talk about that in a few minutes. So therefore I'll multiply by 3, so it gives me 6/3. It gives me x equal to 10 pi over 3. Now I'm plugging in 3. For n. So this gives me x equal to pi over 3 plus 9 pi over 3 multiplied by 3. So x equal to 10 pi over 3. Now I'm plugging in 3 over here. So x equal to 4 pi over 3 plus pi. 1 multiplied by 3. Plugging in 3. Multiplied by 3 gives me 9/3. So x equal to 13 pi over 3. But 13 divided by 3 is 4 1/3. So therefore, this is already bigger than 4 pi. So therefore, we can stop. Now, did you notice something else? What did you notice? Correct. This one's repeated over here. This one's repeated over here. And this one's repeated over here. And that's going to happen every time we have tangent. When we have tangent, because this pi is being repeated every pi, the way the tangent works, we actually don't need both of them. We just need the first one. Because this is just going to be a repetition. So we actually didn't need to do any of this work, only the ones with the first solution, because once you add the next one, in pi, you end up with 4 pi over 3. So therefore, our solutions between 0 and 4 pi, not including 4 pi, is x equals, let me place them in order, pi over 3, 4 pi over 3, 7 pi over 3, 10 pi over 3. And if we look at the graphs, if we compare it to the graphical representation, and we go into decimals, notice that we have 7 power 3, and the last one that we have is 10 power 3. The next one, it's already bigger than 4 pi, and that's why we do not include it. Notice that this repeats every pi. So your solution is 3 pi plus pi is 4 power 3 plus 3/3 is 7 power 3 plus 3/3 is 10 power 3. Example number 3. Find all the solutions. Go and copy it down, and we'll start once you are ready. Go and pause it. So I need to be able to find all the solutions. In this case, I notice I have cotangent and cosine. And I notice that I have a square in there. So just like any other equation that we have a x squared, we want to make it equal to 0. So I'm going to move my cotangent, my two cotangents to the left becomes a negative. So now I have cotangent of x multiplied by the cosine square of x minus 2 cotangent of x equal to 0. And now I need to solve it. They both have cotangent of x, so I'm going to factor the cotangent of x and what's left behind. Cosine square of x minus 2 equals to 0. And because they're multiplying and they equal to 0, I can use my zero product property. So either cotangent of x equals 0 or cosine square of x minus 2 equals 0. And now I can solve it. Now to solve it, remember the cotangent is the reciprocal of tangent. So therefore, if I place it over 1, that means that my tangent will be the reciprocal is 1 over 0, which is undefined. So which angles is your tangent undefined? Or if you want to think about cotangent is your x over your y, so it'll be 0, 1. So by its undefined, 0, 1 is up here and down here, because it can be 0, negative 1, still be 0. So therefore, it's undefined at pi over 2 and at 3 pi over 2. So therefore, x equal to pi over 2 and x equal to 3 pi over 2. Plus, what is the period for cotangent or for tangent? It's pi. But we have the same problem that we did on the previous problem. Every time we have tangent, those two are exactly the same. Correct? Because if you have pi over 2 plus pi will give you 3 pi over 2. So we just actually need the first one. And that's going to happen every time you have tangent or cotangent due to the period being pi. We just need one of them. So now let's go and solve the second part. Cosine square of x equals 2. I'm going to take the square root on both sides. So therefore, the cosine of x equals the square root of 2. But we need plus or minus. So therefore, cosine of x equals to the square root of 2, or cosine of x equals to negative square root of 2. Now, square root of 2 is not one of the values that we know, correct, for cosine. we have 1/2, square root of 3 over 2, 0 or 1, or square root of 2 over 2. So therefore, we're going to have to use a calculator to calculate this. And when I find the inverse cosine of the square root of 2, I want to make sure that I have it on radians. And I do. It gives me error. Did I type it incorrectly? I did. So why is the cosine of x equal to square root of 2 gives me an error? Yeah, because the square root of 2 is about 1.4. And your cosine can be up to 1 and down to -1, up to 1, down to -1. So therefore, this is undefined. And that's why if you actually type it in, domain is undefined. Right? For -1.4, it will also be undefined. It can only be up to 1 and down to -1, up to 1 and down to -1. So the only solution that we have is 1. Now, if you want to be able to find all the solutions between 0 and 2 pi, I can plug in different values for n. Or if I want to find all the solutions between 0 and 6 pi, then I can just plug in a whole bunch of n values to find all of those solutions. Example number 4. So once again, we have a quadratic equation that we need to solve. And in this case, it's already equal to 0. We have x squared, the x, and then the number. So we can actually factor it out the same way that we factor quadratic equations. Factors of 2 sine square of x will be 2 sine of x and sine of x. You can think of this equation as 2x squared minus x minus 1. And there's some students that rewrite it in order to factor. I prefer if you just get used to factoring with your signs. So factors of 2 sine square of x is 2 sine of x times sine of x. Factors of 1 will be 1 and 1. That's a negative, 1 negative, 1 positive. I need to end up with the negative sine of x. So therefore, that'll be positive and that'll be negative. That gives you negative 2 sines plus 1 sine will give you negative sine of x. And because they're multiplying and they're equal to 0, I can use my zero product property. So therefore, we have 2 sine of x plus 1 equals 0, and sine of x minus 1 equals 0. Minus 1 divided by 2. Well, that's not my final answer, right? So therefore, what are the values of sine of x that will give you negative 1/2? What is the value of x? So let me build my x and y axis on the left-hand side. And we're going to be working with radians. Sine, is that your x or your y? That is your x value or your y value? Your y value, right? That's positive, that's negative, so it's going to be on the third or the fourth quadrant. 1/2 is your shorter or longer side. That is your shorter side, so it'll be here, which is 7 pi over 6, and over here, which is 11 pi over 6. So therefore, x equal to 7 pi over 6, and x equal to 11 pi over 6. What is the period for sine of x? It'll be 2 pi. And that will give you all the solutions. How about sine of x equals 1? Correct. Positive 1 will be pi over 2. So for this one will be x equal to pi over 2 plus 2 pi n. where n is an integer. Example number 5. Go ahead and copy it down. See what you can do, and then we can compare our answers. Go and pause it. So in this case, we have a tangent square, so I have a quadratic equation. I'm going to make it equal to 0. So I'll move everything to the left. Move this to the left, you can see -3 or -3 on both sides. Plus 3 tangent of x. And I'm going to write in order. I'm going to place my tangent square first. Then my tangents, so that'll be 4 tangent of x. And plus 2 equals 0. And if I try to factor this out, I'll end up with tangent of x and tangent of x. That'll be 2 and 1. I end up with 3 tangents, but I can't end up with 4. So therefore, this cannot be factored out. So we have a choice. We can use completing the square or quadratic formula. In this case, I'm going to use the quadratic formula. So my a value is 1, my b value is 4, and my c value is 2. But instead of saying x equals, it will be tangent of x equals negative b, so it'll be -4 plus or minus b squared, so it'll be 4 squared minus 4ac. So this is b, a, and c, all over 2a, where a is 1. So we have the tangent of x equals -4 plus or minus 16 minus 8 give me 8 all over 2. So therefore my tangent of x equals -4 plus or minus 2 square root of 2 over 2. So therefore the tangent of x is equal to -2 plus or minus square root of 2. So we have two answers. The tangent of x equals -2 plus square root of 2, and the tangent of x equal to -2 minus square root of 2. And those are our two values that we know. For tangent, we know your tangent of 30 is square root of 3 over 3. Tangent of 45 is 1. Tangent of 60 is square root of 3 over 3. Can be 1 or undefined. Tangent of 45 is 1. So therefore, we're going to use a calculator, and we're going to use them in radians. So I'm going to take the inverse tangent of -2 plus the square root of 2. And that's going to give me x is approximately -0.53. And x is approximately, I'm going to do my second entry, change that to a minus, -1.29. Now, I want the positive version of those two angles. We can leave it as negative, but I prefer the positive version. So what should I do? I should add 360, so I'm just going to add 2 pi. So therefore, I'm going to add 2 pi, and I end up with 5 for this one here. So x is approximately 5.0. And how often, what is the period for tangent? Plus pi n. X is approximately We'll just take my previous answer and add 2 pi will be 5.75 plus pi n. Now notice that I don't need to look for the same answer. So if I actually make an x and y axis for this one, and this is what we did on 10.4, where we need to find the other sign. So negative pi, negative 1 radian is here, 57 degrees. So let's say it's over here. This is an approximation. We don't need to look for the other one that's over here, because we are looking for all the solutions. The pi n is going to take care of it. And yes, we do need to keep both answers, because there are two separate answers. Otherwise, we'll have two answers for this one here, one here, and two answers for this one. But we don't need a second answer for either one. Now, if it was sine, then we will need two answers for each one. If it was cosine, we will need two answers as well. But for tangent, just like we discussed before, the second one will be a repetitive answer, and that's why we don't have it. Questions? Example number 6. So let's make it a little more challenging, correct? So go and copy it down, and then we can work it out together. So find all the solutions over the interval between 0 and 2 pi. Now, what do you notice different from this on this problem? Correct, we have the 3x. Now, what I'm going to do, I'm going to place them in parentheses. I want to make sure that before I get rid of the 3, I need to get rid of the sign. So I need to isolate the sign of 3x. I'm going to move the 1 to the right. And I'll place it in parentheses. Becomes positive, divide by 2. And now I'm going to evaluate the sign of 3x equal to 1/2. So I'll place my x and y axis. We have 1/2, sign is your y value, and it's positive. So y value, negative, positive. So it has to be on quadrant 1 or 2. 1/2 is your shorter side, so it'll be here and here. So it's going to be 5 pi over 6, which is 150 degrees, or 30 degrees, which is pi over 6. Both of them, the y value is 1/2, which is the shorter side. So now we're going to write down 3x equals, instead of just write down x, will be 3x equal to pi over 6, and 3x equal to 5 pi over 6. I'm going to divide by 3, or I'm going to multiply by 1 over 3. That cancels. So therefore, x equal to pi over 18. I'm going to do the same thing here. I can divide by 3 or multiply by 1 over 3. So the 3's cancel. So therefore, x equal to 5 pi over 18. Now, what is the period for the sine of 3x? The period is 2 pi over b. So in this case, it will be 2 pi over 3, since that is your b. So therefore, this will be plus 2 pi over 3, because that's how often it repeats. And that will be all the solutions. So plus 2 pi over 3 n. And now we need to be able to find all the solutions between 0 and 2 pi. So we're going to plug in a 0, and a 1, and a 2, 3 until we get to 2 pi. So let's start. X equal to pi over 18 plus 2 pi times 0. So the first one will be x equals to pi over 18. X equal to 5 pi over 18 plus 2 pi over 3 times 0. That will give me x equal to 5 pi over 18, since that gives me 0. Now I'm going to plug in 1. So what some people do, if they just need to be able to find the solution from 0 to 2 pi, they say, no, that's going to be 1. That's going to be the second one. I'm going to add 2 pi over 3 once I multiply both, and then another 2 pi over 3, and so on. Or we can just go through the process. I'm going to have the same denominator, so multiply by 6. So x equal to pi over 18 plus 12 pi over 18. That gives me x equal to 13 pi over 18. I'll do the same thing here. So be pi over 18 plus 12 pi over 18, correct? So that gives me x equal to 13, oh, this is 5. So it'll be 17 pi over 18. That's still smaller than 2 pi, correct? That's barely a little smaller than 1 pi. So let me plug in a 2. X equal to pi over 18 plus 2 pi over 3 multiplied by 2. X over 18 plus 4 multiplied by 6, so it'll be 24 over 18 pi. So that gives me 25 pi over 18. And I'm going to plug in a 5 pi over 18 plus 24 pi over 18. So it gives me x equal to 29 pi over 18. Now can I plug in a 3? If I plug in a 3, I'm going to end up with x equal to pi over 18 plus 2 pi over 3. That cancels, so this is going to be bigger than 2 pi. So therefore I can stop. So therefore my solutions between 0 and 2 pi are going to be, I'm going to place them in order, so I have 1, 2, 3, 4, 5, 6. So x equals pi over 18 plus 5 pi over 18, not plus but comma. 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. Now let's talk about this algebraic or graphically. I'm not going to decimals, and I'm going to type in the equation. I'm just going to type in sine of 3x, or first I'm going to type in sine of x. So let's talk about sine of x equals 1/2. So I'm going to put g of x equals 1/2. So I'm just going to use this part of the equation, correct? And we want the solution from 0 to 2 pi. So it'll be 0 less than or equal to x is less than 2 pi. So notice that if it was only the sine of x, we will only have two solutions, correct? But what happens if there's a 3 here? It's going to be a horizontal shrink. So therefore, by placing 3, now there are 3 periods in here. And that's why we have now not just two solutions, but we have two other sets. 13 power 6, 17 power 6, 24, and let me actually go backwards. And the last one. And that's why we have 6 solutions. Because if we use only x, we only have those 2 solutions. But once you have a 3 here, then we have a horizontal shrink. So now between 0 and 2 pi, we have 3 different periods. If we only have 2, then we have 2 periods in there. If we have 4, we have a total of 8 solutions, and so on. But in this case, it's only 3. And the last example for today. So see what you get for the following example, and then we can work it out together. Example number 7. So also for tangent, so at this point you should have done it. Move the 3 to the right. I'm going to isolate, and I'm going to place parentheses x over 2. Divide by 3. And now I'm going to evaluate. You cannot multiply by 2 on both sides, and that's why I place the parentheses, just kind of remind you. So we have negative tangent. Tangent is y over x, and it has to be negative. So therefore, it has to be on quadrant number 2 and 4. Negative 1 is your 45-degree angles. So therefore, this one will be 3 pi over 4. And this will be 7 pi over 4. So therefore, now x by x over 2 equals 3 pi over 4. And x over 2 equal to 7 pi over 4. I'll multiply both sides by 2. So therefore, x equal to, I'm going to reduce. So 3 pi over 2. Multiply both sides by 2. That cancels, so therefore x equal, I'm going to reduce 7 pi over 2. Now, what is the period for tangent of x over 2? Remember, the period is for tangent is pi over b. In this case, the b is 1/2. So therefore, your period is equal to 2 pi. So therefore, it will be plus 2 pi n. Now, do we need both of them whenever we have pi? We don't, correct? Because this is going to be repeated. This is already taken care of. This will take care of this one as well. Because if you add 2 pi, 3/2 plus 2 pi, that's over 1. So it'll be 3 pi over 2 plus 4 pi over 2 will give you the 7 pi over 2 that we have there. So whenever you have tangent, you actually don't need the second one because that's going to take care of it. Now, I need to be able to find all the solutions between 0 and 2 pi. So I'm just going to plug in numbers. Let's go and plug in a 0. And we know what happens when you plug in a 0. That gives you I'm going to plug in a 1. That's still smaller than 2 pi. So 3 pi over 2 plus 2 pi times 1. Well, this is already 2 pi. If I'm going to add something, it's going to be greater than 2 pi. So therefore, we only have one solution. So my solution is x equal to 3 pi over 2. Solutions for the interval between 0 and 2 pi. And let's look at this graphically. So let's go into decimals. Once again, I'm just going to graph this part of the equation. And I'm going to leave it from 0 to 2 pi. And I'm going to type in, first let's type in tangent of x. And this will be -1. So if it was tangent of x, then we will have two solutions, right? But what happens if you have a 1/2 on as a coefficient for b? So what happens if you have a 1/2? Then that's going to be a horizontal stretch. So therefore, as you place it, you can divide by 2. Then that guy horizontal stretch. So therefore, we only have -1. Where's my 3/2? It's my only solution. Questions? So if this was from 0 to 4 pi, then we will have one solution, the second solution. But in this case, we only have 2 pi, and therefore we only have one solution. So this will conclude the lesson for today. Have a great day, and I'll see you next time.